So we've covered matrix multiplication, and now we want to look at naturally how we can divide as such. And it turns out this is not possible with like just a simple rule like with multiplication or dividing as we normally would. With matrices you can't divide by a matrix, so we have to look elsewhere. If we look at the regular numbers, say we take 3 and we divide this by 3, which is equivalent to doing 3 and multiplying it by 1/3. This is equal to 1. And for the real numbers, or the integers, this is essentially our identity element. Meaning, if you take n in z, 1 multiplied by n is equal to n multiplied by 1 is equal to n. Okay? And 3 here, we call this 1/3, the inverse of 3. And it's called the inverse because 3 times 1/3 is equal to 1/3 times 3 is equal to this identity element. So we can do a similar thing with matrices, and the reason we do that is because for the normal numbers, you see, if we want to divide by 3, if we've got some equation 3x is equal to 9, well, we just divide by 3, we get x is equal to 3. Fantastic. But with matrix equations, if we want to solve and we want to sort of neutralize some matrices, we can't just, if we've got a matrix A in some equation, right, we can't divide by A. That's not an available operation. So now we're going to look at specifically just for 2 by 2 matrices how we can find the inverse, and we can define what the inverse actually means in terms of matrices. It's very similar to this definition for the integers. So let's have a quick look. If we've got a matrix A, and that's equal to A, B, C, D, but A could be any square matrix, right? So we can only find, that's an important note, we can only find inverses of square matrix. Can only invert square matrices, and the inverse is defined, we call it A inverse, or A to the minus 1 to A inverse, but that's how we write it. And if we have A inverse, we have that A inverse multiplied by A is equal to A multiplied by A inverse is equal to something called the identity element, which in matrices is this matrix here. For 2 by 2 but if it's 3 by 3, we have just another 1 on the diagonal, so it's just 1s across the leading diagonal with 0s everywhere else in the matrix. That's the identity, okay? Another important note before we get into it, not all square matrices have an inverse, and we'll see this in a minute. Have an inverse, and when you see the method, we can find the conditions for when a square matrix does not have an inverse. So we've got A is equal to A, B, C, D, and to find A inverse, what we have to do is we take 1 over AD minus CB, and this thing on the bottom is called the determinant, and we'll come back to that in a minute. And then here we swap A and D around, and we change the sign of C and B. And you can see now when you can't get the inverse of a matrix, and that's when you have a square matrix where this that I've just circled is equal to 0, because you can't divide by 0. Okay, so if AD minus CB is equal to 0, we say A is singular, and singular just means it doesn't have an inverse. Alright, so I think that's going to be it for this video. I hope this was helpful on finding the inverse of 2 by 2 matrices. We're going to look at inverses in higher dimensions in the next couple of videos, which is a little bit longer, and then so we'll look at 3 by 3, and then we'll come up with a general formula for all size square matrices, which I think for exams you never have to calculate more than 3 by 3 because it's just a waste of time, but you might want to understand it, especially if you're interested in this stuff. Hope you enjoyed this video. Please like and subscribe if you did, and I hope to see you in the next one.